Jeff. My name is Tom Parks. I'm from LMI. I'm a senior fellow there. LMI, or Logistics Management Institute, is under direct contract with the Defense Logistics Agency, DLA. And I'm here on their behalf today. Full disclosure, I'm a contractor, so I can't speak for them, all right? You can't hold me accountable for things they make decisions on. But I'm joined by two of my colleagues here, Dick Tiano and Scott Truitt over here, both from ATI. They are my subject matter experts for all things 3D. They keep me out of trouble, and which is a full-time job. But we have been working on a number of R&D projects for DLA for 4 or 5 years now, and so that's what I want to talk to you about today. Is one of those projects. So let's see. Yeah. All right. So let me kind of set the stage here with a little bit of background, and then I'll define the issue, the problem for you, and we'll walk through the solution. Then I'm going to give you the outputs of this practical application of PDF, and specifically 3D PDF, to solve a major issue that the government deals with every day. So for those of you who are not familiar with Department of Defense and with DLA, or Defense Logistics Agency, think of them as the Walmart of the Department of Defense. If there's a soldier, sailor, airman, Marine out there that needs something, fuel, medicine, food, parts, whatever it is, and they don't have it in stock, they send a request to DLA, and DLA buys it. All right. As part of that job, DLA has to, one of the things they buy is repair parts, and that's what I'm going to talk about today specifically, is the need to acquire spare parts that need to be manufactured. All right. DLA doesn't build anything themselves. Instead, they go to private industry, right, and they ask, all right, for bids to manufacture products for them. So there's a certain amount of information that they need to pass along to the suppliers. They sign a contract, and then hopefully they get what they contracted for. Well, to kind of help that along, especially in a 3D world of today, we've found that 3D PDF is a solution for that. So again, DLA buys lots of parts. Most of those parts that they buy today are rendered as 2D drawings, have been for a long time. Legacy systems have been around for quite a while, right? But that is not the way parts and systems are designed anymore. They're made with 3D models. And for years, the Department of Defense has been asking contractors to model things, go and build it, and then provide to them technical data as a 2D drawing. Well, it's kind of going backwards. And I would tell you that the day is coming when the manufacturers are going to stop and tell the Department of Defense, no more, I will not do 2D drawings. That day's already here. It's already happened. There are a number of manufacturers that are saying, I'm not going backwards, you get a model. All right? So DLA, as well as the rest of the Department of Defense, is going, well, that's nice, but if I want to go manufacture or have somebody manufacture something, how do I pass that model along in a format that somebody can use? That's the crux of the situation. All right, so here's their problem. DLA's built to use 2D data. They know how to use 2D drawings very, very well. And most every manufacturing company that's out there knows how to use 2D drawings too, but that's not the way they build things. We give them a 2D drawing, what do? They build their own model so that they can import that model information into their CNC machines and make the part. Well, again, we're making them doing a lot of, redo a lot of recurring engineering that doesn't need to be done. And it costs us money and it costs us time. So how do we get around that? All right, because 2D is the way of the past, 3D is here today, and it's going to be around for a long time. So how do we get there? DLA recognized that it needed to have a capability to use 3D some years ago. They also recognized that they didn't know how to do that. So they put us under contract and said, go out and figure out what the problem really is and tell us how to solve it. So as we looked at that problem, we realized that there's really three components to the overall problem. There's three things that whatever the solution is has to be able to account for. One is, if I give this solution to the folks, the acquisition people who are not technical experts, they are not engineers, can they use that solution to actually look at whatever it is that they're going to buy? Can they see that part? They have to be able to see it. They have to be able to understand what it is, not evaluate whether or not the dimensions on there are correct, but are the dimensions there? All right? Which brings me to the second part of that. They've got to be able to find that information. I can give somebody a viewer. In fact, DLA has viewers. And they can look at a model that they're given in a proprietary CAD format. The problem is, all they can see is the geometric shape. They can't find the metadata. They don't know if it's made out of metal. You know, is it Inconel? Is it made out of plastic? They don't know what kind of heat treating processes go with it. All those other pieces of information that are required in order to actually build something are buried somewhere within that model. So they've got to be able to find that information. And every flavor of CAD software that's out there is different. So they're going to have to, you know, figure out how to get around that particular issue. And there is DLA, there's some 40-some odd data elements and attributes. I know that's a bit of an eye chart. I apologize. But since you're going to be getting the slides anyway, you'll be able to read that up close and personal later. These are the things that DLA has as a requirement. When they get a technical data package in, they need to be able to find all that information. Whatever up there is applicable. Not everything there is applicable to every part. But at a minimum, they need to be able to see what the dimensions are, what the tolerances are, those sorts of things. They need to know what kind of material it's made out of. Are there special processes or coatings that have to be applied to this particular part? They got to be able to find that. Again, not to judge whether it's right, but just know that it's actually there, so that when they pass that to a contractor, a supplier, they know that the supplier can do, you know, can find that as well. And that brings me to the last issue, which is can actually be the deal breaker, which is whatever DLA, as the federal government's agent, puts in a contract and puts out on the street, has to pass the fairness paradigm. So if I put a model in there that's a native CAD file, and let's say it's CATIA, I put it out for bid, there's some shop out there that says, well, I don't have CATIA. I can't read that. I got Creo, all right? Or I got NX, or I got, you know, whatever. I can't read that. Wait a minute, this is not fair. I'm being precluded from bidding on this contract because I don't have the software that somebody else chose. And you know how that goes, right? Pick the phone up, call the elected representative, I got a problem, protest. So now what happens is everything gets held up, right? There's somebody out there on the front line that needs that part that's not getting it right now because we got a protest going on, right? So DLA's got to solve that problem, all right? How do I get it to these people without having a protest? So recognizing that those were the issues we had to deal with, we picked a number of options. These are just 3 that we looked at. And we said, all right, well, there's lots of flavors of CAD software out there. Let's just go buy one of each and every variant thereof and all the training that goes with all that, and we'll teach the 1,000-some-odd employees at DLA how to use that. Okay? That's one option. The other one is federal government, you pick a winner. Pick one software and we're going to use that and stick to that. Okay? The last one is let's try something neutral that everybody can take a look at, whatever that might be. So those are the options that we looked at. So how do those options fare against those 3 issues that I just enumerated for you a minute ago? All right, options are down the leftmost column, and the issues are over in columns 2, 3, and 4. So you can see that for the first 2 options, it will solve 2 of the issues at rather high cost, but they will solve those. The deal breaker is the last one over there. In all cases, for those first 2 alternatives, it requires the supplier is going to have to go buy proprietary software, and that's just not going to work. All right, federal government's not going to be able to get by with that. So that leaves us with the third option down there, which neutral files happen to work very nicely in all instances for this particular problem. So there are many forms of neutral formats, and I'm sure as you've all guessed by now, we picked 3D PDF as the preferred format. And I'm not going to get into all the details of that. If you want all the gory details of that, at the bottom of this page under footnote number 1, there's a concept of operations paper that details all of that for you. But at the time we looked at this, and even today, I will tell you that we are convinced that for the moment, the 3D PDF solution, or a 3D PDF file accompanied by an appropriate step file, all right, is sufficient to meet all those requirements and allow the government to purchase items, all right, to solicit for and go under contract and have suppliers build the items using 3D technical data. Okay. So it's nice for me to say that, and I can show you all the words that go along with that, but how do we know it really works? So that's where the R&D comes in. We actually ran acquisitions. We used the current procurement process that DLA runs, and we went out and bought parts, right? We used only 3D files and step files. That's all we gave the suppliers. They got no 2D drawings. They got nothing beyond what was normally in a contract, and a 3D PDF file and a step file to go off and build the parts that we were asking for. So the intent here, all right, was to test the end-to-end process, all right, from creation of a 3D PDF to the delivery of a part and the validation of that part against the data of record, which is also the 3D PDF. Okay. Our demo included 3 different parts here. You can see cable sheave, guide, a brake shoe, cam, and a retaining bearing plate. Those 3 parts were managed, or the data for those parts were owned by 3 different services. All right. The first one there is Lakehurst. Second is the Army, Arctic at Rock Island, and the third is Air Force at Warner Robins. So we had 3 different parts from 3 different services, managed and procured by 3 different supply chains within DLA. So we had a nice cross section here. Everybody got to play. We made sure that everybody could do this regardless of which supply chain you're in, which service you were in, or what the parts were. So we had, I guess most of these were relatively, I'd say moderate complexity parts. All right. So again, the demo is to test the end-to-end process, which you see here starts in the upper left-hand corner. So again, everything from, where's my pointer here? Everything from creating a PDF template that's necessary in order to have a 3D PDF output file, all right, taking that template and providing it to DLA to make sure that all those data elements and data attributes that I showed you before are resident someplace in that template, all right, and then actually creating the file for the parts that you want to build, passing those parts to DLA by whatever manner that is normally done, all right, make sure that DLA can actually get the files, and then DLA goes through its in-house process of validating that all the requisite information is there, that they can see it, that they've got what they need, that they can pass on to a supplier. They build a solicitation, they post it out on the web, all right. Suppliers come in and bid just like they normally do, and then DLA goes through the process of picking a winner. Once they pick the winner, they decide who's going to build the part. They award a contract. It goes back to that supplier. They build the part, again, using only a 3D PDF and a step file as their technical information for that. Parts delivered to the engineering service activity who owns the technical data. They do the validation test of the parts as delivered against the 3D PDF, which is the data of record, all right? And that's the process that we went through. So now I'm going to tell you about how that unfolded, at least the results of that process. So I'll take the first one, the cable sheave guide. Rather interesting test case. This is the first one that we put on contract and the first one to deliver. The company that built this thing, that bid on it and built on it, never seen a 3D PDF before, never worked with one. All right? They didn't have any problem bidding. We asked them as part of the contract. We said, you know, were there problems using this format? Did you guys have issues with any of it? No. It took us a little longer because we hadn't seen a 3D PDF before, but they figured it out. We asked them to deliver this part in 60 days. Normally they get about 180 to build this part. So they did it in less time than we normally give. All right, they didn't have any problems figuring out what the technical documentation was. So they delivered the test articles. The ESA took them, validated them, and found 2 minor nonconformances. All right, so in layman's terms, what that means is, had this been an actual procurement to go into the supply chain and go on a weapon system, those parts would have gone. They'd have been stocked because they met all the requirements of the technical drawings, the technical data in the 3D PDF. And by the way, those 2 nonconformances had nothing to do with the data. They were production things. All right. In one case, this cable sheave guide has 2 arms that stick out about 6 inches, so they're flexible. All right. Well, there's some minimum distance between these two. When they measured that distance, it was just slightly under. All right. Takes just a little bit of pressure from your fingers, and now they're in spec. So that's the kind of nonconformance that existed. Again, had nothing to do with the documentation. Had everything to do with production. Okay. So in my mind, this is the perfect test case. All right. We put this thing out on the street, multiple companies bid. We got a company that never played with 3D PDF before, and they were able, you know, absolutely successful in producing this part in less time than we normally asked for. So, you know, an unqualified success in my book, and in DLA's book, frankly. Right? So the second part here. In this case, we went to an organic manufacturing facility, all right? An Army facility, Picatinny production integration facility. Now, they had seen 3D PDFs before, but they hadn't built anything using one. They didn't have any problem either. So they delivered on time, you know, within budget, and again, they had minor nonconformance, but it had nothing to do with the documentation. It had everything to do with the production. And again, the nonconformance was not such that they'd have to disqualify that part if they actually wanted to put it in the supply chain. And I should point out that none of these parts went into the supply chain because they were bought with R&D dollars. So legally, we couldn't do that. And we returned the parts to the ESA for them to dispose of as they saw fit. So the parts are back there. All right. The last case, again, I should have mentioned, the first part was that we had was a Lakehurst, a Navy part that was procured by the troop support supply chain out of Philadelphia. The second part was an Army part that was procured by the Land and Maritime Division out of Columbus, Ohio. This part that I'm talking about here is an Air Force of Warner Robins part that's being procured by the Aviation Division out of Richmond, Virginia. All right. In this particular case, the part has been built. It's been delivered to the ESA. We're just waiting to hear the results right now. You know, holidays kind of slowed things down, but I have no doubt that the end result will be similar to the other 2 projects. That it'll be a complete success. So the point is, we went out and tried it. We not only said you can use a 3D PDF and a step file, we proved it. We went out and had people build these things. And we talked to the other bidders who were non-successful. We asked questions and said, did you have problems reading the documentation? Was it intuitive? Could you use it? The answers were all yes. Nobody had an issue with any of that. So DLA has effectively proved at this point that it can use 3D PDF and step files as a means to transmit 3-dimensional models to its supply base and have parts built using only that information. Okay, something that hasn't been done before. All right, the suppliers have proved that they don't have any problem operating with that. In fact, if you ask them, most suppliers would tell you, I'd rather have 3D data because I don't have to go, you know, build my own model before I go make this part. The other parts of this, the ESAs, we have 3 ESAs. One of here who's represented here, Jeff Wyndham, he's the RDEC rep. We've proved that their templates, all right, work for DLA for procurement of material. I can also tell you via a couple of other projects that we have worked simultaneous with this that it works for the provisioning activities, the service provisioning activities, and for the cataloging activities. Everybody has got to put all this information into the federal catalog so we can find these parts when we need them. A 3D PDF solution solves all their issues because they have the same problem, all right? They don't have CAD software, they don't have the engineers to read it, they don't have the training, and they can't see it. So they've got to figure out how to make that work. 3D PDF solves that problem for everybody. All right, so as I said there, the 3D PDF solution works. We know it works. Here's all our contact information. Full disclosure, I'm retiring at the end of this week, so if you want to know more about this particular project, you need to talk to one of the other folks. I suggest that you talk to Dick Tiano. He's hiding over here behind the column because he knows I'm going to point at him when I get a hard question, because I don't do hard questions anymore. So, but with that, I'll open it up to questions. Thank you.
Thanks very much, Tom.
So, yes, ma'am. Do I have an example of a 3D PDF? I do not have one here, but let me describe it for you. If you've ever seen a regular 2D drawing, all right, looks very, very similar to that. The difference is that when you see the rendering of the geometric shape in the drawing, with the 3D PDF, you have the ability to pan, rotate, zoom. You can flip that thing all around. And I can tell you the suppliers love it because now all the ambiguity about, well, what does that look like on the back side? That's all gone. There is no issue with that anymore. Sir?
What are your requirements for long-term retention on these files?
So the question is, what are the requirements for long-term retention of these 3D PDF files?
Yeah. That's up to the engineering service activities, the ESAs. They own the data. DLA is a user of that data.
What's the minimum and maximum, roughly? Is it lifetime of the part?
Yeah, it's the lifetime of the part. I mean, that can be anywhere from 10 years to, 75 years. I mean, look at the B-52. It's still around. So, yeah, it can be a very long time. But DLA, frankly, DLA doesn't set that. We're a user of the information, so whatever, if the services keep the weapon system in service and they deem that part needs to be procured, then it's their responsibility to keep the data available for DLA, and they provide it to DLA. So we are strictly a consumer of that information.
I will say the services haven't solved that problem yet.
So.
The long-term storage has not been solved yet.
Yeah. Yes, sir.
I'm interested in knowing how the 3D data is originally authored. So, does DLA as a supplier get provided these CAD files?
No, DLA. The question is how is the 3D PDF originally authored? There are
or the 3D data.
Or the 3D data. Okay, the 3D data, as a rule, models are built by the original equipment manufacturer. All right, they do all the modeling, in whatever CAD package they happen to have. There are a number of ways to produce 3D PDF documents. Some CAD platforms, a few, I guess I know of one, right? SolidWorks has a 3D PDF plugin that you can buy that will render a 3D PDF file for you in sufficient detail that you could build something from it. All right? There's.
Autodesk Inventor will export the 3D PDF.
I'm sorry?
Autodesk Inventor will export the 3D.
Okay, thank you. We haven't worked with Autodesk. We'd like to talk to you, please. You can also buy third-party software, all right, and render a 3D PDF.
You have the CAD files yourself?
No.
So
The engineering service activities, the ESAs who own the technical data, they are the ones who are responsible for, they may or may not author. It's up to each individual ESA as to how they do it. In some cases, the OEM authors it if it's in their contract. In other cases, the ESA may do the authoring. So it just depends on whatever. But DLA doesn't author anything. We're a consumer of that information. They provide it to us. We take the package as it arrives. So, Jeff, I've got an ESA right here. I'll let him tell you exactly how this works.
I was going to say, in all three cases in the pilot that Tom talked about, the authoring software was Creo, and we used Anarch to translate that into 3D PDF, and each service's unique template. and that was what was provided. So in those three cases, it was a Creo and our tool to bring it over to the
Okay, and is all the product manufacturing information embedded in the 3D model?
Yes.
And so in that case, you're using the ARC technology to turn the CAD data into PRC, and then you're using the ESA templates
Yes.
to put them into a 3D.
Yeah, the Navy
Right.
Linkers has their template, the Army has their template, and the Air Force has their template. They're very similar. You just get something there and put on the template.
Right. And then the step files are provided as the shortcut to building the model, right? Here's your model, you're gonna have to validate, or not validate, you're gonna have to check that what you loaded into your machine actually represents what's in the 3D PDF. So, you're welcome. Any other questions? Thank you very much, appreciate your attention.